Hello everyone, welcome to this video. I, Varisha Ansari, final year student of BTech Civil Engineering from Faculty of Engineering and Technology, University of Lucknow. I am pleased to present my seminar on the topic of performance of steel plate reinforced concrete composite shear wall. In short, it is also termed as SPRC Composite Shear Wall. Let's switch to the content part. These are the content on which I am going to explain you in brief, starting with the introduction and then problem statement. Further, I will tell what are the benefits of using SPRC composite shear walls and its material properties. After that, I will compare traditional reinforced concrete wall and SPRC composite shear walls, and then I will tell types and components of SPRC shear walls. Further, I will show some real world applications and some popular case studies, and then I will include conclusion and references in my video. Moving to the next slide. Let's get to know what is SPRC wall. The steel plate reinforced concrete composite shear walls are the structural elements used in buildings and infrastructure to provide lateral resistance against forces such as wind and earthquakes. SPRC composite shear walls are important in constructing safe, resilient, and sustainable buildings, particularly in seismically active regions. And the objective is to evaluate performance of SPRC composite shear wall. Let's move to the next slide. Problem statement. Before we move on SPRC, let's first examine the limitations of traditional or reinforced concrete walls. Traditional reinforced concrete walls have certain limitations, including inadequate seismic resistance, restricted ductility, vulnerability to failure, and need for additional reinforcement. Taking into account these limitations, we are now proceeding to explore SPRC composite shear walls. Now, let's move to the benefits of SPRC composite shear walls. The SPRC composite shear walls offers several advantages which we will explore one by one. The first one is structural benefits. By using SPRC composite shear wall, we can enhance seismic resistance up to 45% and can improve 30% structural stability and 25% increase is seen in ductility and 40% reduced damage under lateral loads. The second one is environmental benefits. The SPRC composite shear wall use 10% less material than the traditional reinforced concrete wall, and it lowers 15% carbon footprint also. The third one is design and constructional benefits. In SPRC composite shear wall, 20% reduction seen in wall and it increases load capacity up to 15% and fewer reinforcement bars is used and the formwork is simple. So it reduces construction cost also. The fourth one is economic benefits. In this, we can see by using SPRC composite shear wall, construction time is reduced up to 15% and it lowers 20% maintenance cost. Let's move to the next slide. Material properties. The SPRC composite shear walls mainly contains two material, which is one of them is steel and second is concrete. In SPRC shear wall, high yield strength bars are used, and the yield strength of steel is 345 megapascal and ultimate strength is 450 megapascal. And in concrete, it is used design mixed concrete and the compressive strength is 30 megapascal and tensile strength of concrete is 3 megapascal. Here you can see the stress strain diagram for steel and concrete, through which we can analyze the behavior of steel and concrete. Let's move to the comparison part of traditional RC walls and SPRC composite shear walls. With the help of this graph data, you can easily compare SPRC composite shear wall and traditional reinforced concrete walls. The graph shows that SPRC composite shear walls, the strength and ductility are increasing, outperforming traditional reinforced concrete wall. Additionally, SPRC walls also shows a reduction in weight and construction time compared to reinforced concrete wall. However, its overall cost is slightly higher compared to traditional reinforced concrete wall. Moving forward, types of SPRC composite shear wall. The SPRC composite shear walls are basically of two types. The first one is single-sided steel plate composite shear wall. In this, a steel plate is placed on only one side of the concrete core. It is used when there are space or weight constraints. It is utilized in retrofitting or when one side of the wall is exposed to the different loading conditions. The second one is double-sided steel plate composite shear wall. This type of shear wall has steel plates on both sides of the concrete core. These plates these plates serve as reinforcement and provide additional strength and ductility. It is used in high-rise buildings, nuclear structures, and other areas requiring high lateral resistance. Continuing to the components of SPRC shear wall. SPRC composite shear wall consists of three main components, including steel plate, reinforced concrete, and shear connectors, where steel is embedded in concrete with the help of shear connectors. While SPRC composite shear walls offer several advantages, it also presents certain challenges and limitations. Let's examine the challenges and limitations of SPRC composite shear walls. Construction cost is high in SPRC walls due to the use of specialized material and labor. And the design is complex and the construction process requires specialized and expertise. And also the risk of steel corrosion is high, which can impact durability and structural integrity of the structure. Now that we have covered the basics of SPRC composite shear walls, let's move on to its implementation. The SPRC shear walls can be utilized in high-rise buildings, bridges, underground structures, sea crossing bridges, skyscrapers, art museums. Here you can see the real-world examples of SPRC composite shear walls. Now let's proceed to case studies of SPRC composite shear walls, highlighting instances where they have been successfully implemented. The first case study is Tokyo Skytree, Japan. It is located in Tokyo, Japan. The Tokyo Skytree stands at an impressive height of 634 meters. It is designed by architectural firm Nikken Sikki. This iconic tower was developed by Tobu Railway Corporation Limited and Tobu Tower Skytree Corporation Limited. The SPRC shear walls were employed in the foundation and lower level of this 634-meter tall structure. Continuing to the further details. The structural system of Tokyo Tower incorporates 6-meter thick SPRC composite shear wall in the foundation and 4-meter thick SPRC composite shear wall in the lower levels, and the steel frames with concrete core in the upper levels are used. It has been designed for high seismic zone with consideration for wind speed of up to 215 km per hour, soil condition comprising soft clay and sand. Tokyo Tower's design includes 10 mm steel plates, 40 megapascals reinforced concrete, and 2% steel reinforcement ratio, and bonded interface conditions between an steel and concrete. Continue, Continuing to the test and results. Through comprehensive testing, including shake table test, which is conducted at the University of Tokyo to stimulate seismic loads, and finite element analysis, which is performed to validate structural performance, and on-site monitoring of the structural performance during construction and operation. Tokyo Skytree demonstrated exceptional performance, achieving a 42% increase in seismic consumption, seismic resistance, 20% reduction in concrete consumption, and 28% improvement in structural stability, 15% increase in construction time, and lower maintenance cost. Moving forward, conclusion. The Tokyo Skytree project demonstrates the effectiveness of SPRC composite shear wall in reducing material uses, enhancing seismic resistance, improve structural stability, and enhancing durability. The project showcases the potential of SPRC composite shear walls in high seismicity areas and complex structural systems. Let's move to the next case study. The second case study is Bengaluru Metro Rail Corporation Limited, Karnataka, India. It is situated in Karnataka, India. The Bangalore Metro Rail project was designed by renowned architect Ram V. Sutar. The Bangalore Metro Rail Corporation Limited has constructed an elevated viaduct spanning 21.25 kilometers. The project involves buildings, 33 stations, 13 interchange stations, and 124 pier locations. Continuing with the further details of Bangalore Metro Rail project. The BMRCL structural design comprises SPRC composite shear walls of 6-meter and 4-meter thickness at foundation and lower levels, respectively, supplemented by steel framing with concrete core at upper levels. It is designed for moderate seismic zones. BMRCL structural configuration takes into account wind loads corresponding to velocities of 180 km per hour, soil conditions characterized by soft clay and sand, and it is designed for load capacity of 3,000 tons. The BMRCL structural elements comprise 10 mm thickness steel plates, reinforcement, high strength reinforced concrete with a compressive strength of 40 megapascal and a steel reinforcement ratio of 2% bonded interface condition between steel and concrete. Let's move to the next slide. The BMRC underwent rigorous testing, including shake table tests conducted at IIT Madras to stimulate seismic loads, finite element analysis performed to validate structural performance, and on site monitoring of structural performance during construction and operation. The comprehensive testing program revealed significant advantages. Seismic resistance increased by 40, concrete consumptions reduced by 18%, structural stability is enhanced by 30%, construction time decreased by 15%, and maintenance cost also reduced. Let's move to the conclusion part. The BMRCL project demonstrates the effectiveness of SPRC composite shear walls in enhancing seismic resistance, improving structural stability, reducing material usage, and enhancing durability. The project showcases the potential of SPRC composite shear walls in Indian infrastructure development, particularly in seismic prone areas. Now that we have thoroughly understood and grasped all aspects of SPRC composite shear wall, let's proceed to the conclusions. The steel plate reinforced concrete composite walls represent a revolutionary advancement in construction technology. As the demand for sustainable and resilient structures grows, their role will become increasingly vital. Future innovations will likely enhance their performance and applications across various sectors. Finally, I would like to acknowledge the sources that have contributed to this presentation. The references listed below are from various research papers and studies. I hope this presentation has provided valuable insight. Thank you.